Good afternoon. Hello everyone. Good afternoon. Myself, Anjali Ramashankar Prasad. I'm a PMRF scholar at IIT ISM Dhanbad. So today we are going to start with week 3 assignment session solving of numerical methods. Course code is NOC 23 MA94, taught by Professor Amir Kumar Nayak and Professor Sanjeev Kumar from IIT Roorkee. Okay, so let's wait for 1 or 2 minutes, then we'll start with the session.
हमारे
हाँ, hello. Hello. Mona Lisa, you want to say anything? Am I audible? Am I audible? Shall we start? So our first question for week 3 session is let M1 equals, we have been given two matrices, M1 equals matrix 1 1 0 1 and M2 equals matrix 0 1 1 0. Okay, so you have two matrices, then you have to find out that which of the statements are true, is or are true. So first says that only one M1 is diagonalizable. So you have to find either M1 is diagonalizable or M2 is diagonalizable, or both are diagonalizable. So solve it and find out which of these are diagonalizable. M1, M2, both M1, M2, or none of them. So for finding out whether it is diagonalizable or not, you first need to calculate its eigenvalues, then eigenvector corresponding to them. Then you have to calculate the algebraic multiplicity of the eigenvalues, and for respective eigenvalues, you have to calculate its geometric multiplicity, right? And after calculating that, if you will get algebraic multiplicity equals geometric multiplicity of all the eigenvalues, then you can say that though that matrix is diagonalizable. Okay, so proceed in that manner. First calculate the eigenvalues and tell me the eigenvalues. What are you getting? So again, I am repeating the question. You have been given two matrices M1 and M2, and you have to find out which one of these is or are diagonalizable. So for proceeding, you have to calculate its eigenvalues and respective eigenvectors, so that you will get algebraic multiplicity of each eigenvalues and geometric multiplicity. Okay. If algebraic multiplicity of all the eigenvalues will be equal to geometric multiplicity, then that matrix will be diagonalizable. So calculate it and find out which one of these are diagonalizable. Have you found the eigenvalues and eigenvectors? Which one you are getting? Tell me. If you have any doubt regarding this, you can ask. Tell me which option is correct. Have you calculated? So you will get, for the first matrix you will get the eigenvalues. So 1 and 1. So algebraic multiplicity of 1 is 2, and its geometric multiplicity, when you will calculate, you will get it as 1. Okay, so you will see here that algebraic multiplicity is not equals geometric multiplicity. Hence, M1 is not diagonalizable. Fine. And for matrix M2, you will find that you will get algebraic multiplicity equals geometric multiplicity for all the eigenvalues. That's why M2 is diagonalizable. Are you getting it? So here you can see how to solve it. So if you have given a matrix, so it is diagonalizable if and only if its algebraic multiplicity equals geometric multiplicity, okay, for each and every eigenvalue. So when you will consider matrix M1, that is 1 1 0 1, so calculate its determinant, that will be 1 minus 0, that will give you 1. Now what is trace of M1? Trace means you will have to add the diagonal elements. So 1 plus 1 equals true. Now characteristic polynomial of M1 is, so formula is x square minus trace times x plus its determinant. So here you will get equation as x square minus 2x plus 1 equals 0. Fine. That is x minus 1 whole square equals 0. So algebraic multiplicity of 1, here you will get 1 root as 1, and you will get it as twice. So its algebraic multiplicity is 2. What is algebraic multiplicity? It is how many times you are getting your root, that eigenvalue. So it is coming twice. So its algebraic multiplicity is 2. Now for eigenvector you will consider Ax equals that eigenvalue lambda times x, that will give you A minus, since it is in a matrix form, so when you will take common it will become I, identity matrix. Fine. So A minus I times x is equals 0. Now this A matrix is what we have given it as M1. So M1 minus I into x is equals 0. Now what is M1 matrix? This. When you will subtract identity matrix from this, that is 1 minus 1, this will be 0, and again 1 minus 1, this will be 0. So you will get this matrix into X matrix is given by x1, x2 equals 0 0. Therefore from here you will get x1 equals 0. Now for calculating its geometric multiplicity, we will calculate E1 equals, so set E1 is given by x1 comma x2 belongs to R2, such that here what we are getting, x1 equals 0. Okay. So for calculating eigenvector, this set we have considered where x1 equals 0. Now when you will put x1 here as 0, you will get this set 0 comma x2, where x2 belongs to real numbers. So this will be what? You can write it as 0 comma 1. Fine. So geometric multiplicity of 1 is, here how many vectors we are getting? Only one linearly independent vector. So geometric multiplicity of 1 is 1. Fine. Therefore, here algebraic multiplicity of 1 was 2 and geometric multiplicity of 1 is 1. So AM is not equals to GM. That's why this matrix M1 is not diagonalizable. Hope you are getting it. Similarly, you have to do for matrix M2. Okay, try it. So have you got this? Now similarly, when you calculate for matrix M2, that is 0, 1, 1, 0. So here determinant will be what? 0 minus 1. So determinant of M2 is minus 1. Now trace of M2 is, trace means you have to add the diagonal elements. So you will get 0 plus 0 equals 0. Fine. Now characteristic polynomial, similarly from here you will get x square minus trace into x plus determinant, that is x square minus 1 equals 0. So here from here you will get x as value of x is equals plus minus 1. So here you are getting two eigenvalues, 1 and minus 1, and both of them are coming here only once. So algebraic multiplicity of 1 is 1, and similarly algebraic multiplicity of minus 1 is 1. Fine. Now we have to calculate the eigenvector of 1 corresponding to 1 and corresponding to minus 1. So for corresponding to 1, when you will take M2, x is equals 1 into x. So when you will take that 1x to the left hand side, you will get M2 minus I into x is equals 0. Now when you will calculate this matrix M2, so 0 minus identity matrix 1, first element is 1. So 0 minus 1 you will get minus 1. Here 1, and in identity matrix the first second element is 0. So 1 minus 0 is again 1. Similarly here you will get 1 and here you will get minus 1. Fine. Multiplying it with x1, x2 vector is equals 0, 0. Now when you will solve it, you will get minus x1 plus x2 equals 0 by matrix multiplication, and here you will get x1 minus x2 equals 0. Fine. So you will get x1 equals x2. Now for calculating its eigenvector, consider this set E2 equals x1 comma x2 belongs to R2, where x1 and x2 will belong to real number. Fine. Now since x1 is equals to x2, so at the place of x2 we can put simply x1. So you'll get x1 comma x1 such that x1 belongs to R. So this will, you will get only one linearly independent vector, that is 1 comma 1. So geometric multiplicity of eigenvalue 1 is 1. Fine. Similarly, we will calculate the algebraic multiplicity of minus 1. So for that, when you will take m2x is equals minus 1x. So when you will take it at on left hand side, you will get m2 plus I times x is equal 0. Now matrix m2 plus I, that is 1, 1, 1, 1. I will get m2 matrix is this, and in identity matrix here and here it will be 1. So adding all this, you'll get 1, 1, 1, 1. Now here you will get x1, x2 equals 0. To solve it, do matrix multiplication. You'll get x1 plus x2 equals 0. And this will imply that x1 is equals minus x2. So when we will form by the same method, you will get that geometric multiplicity of minus 1 is again 1. So here for both the eigenvalues, you have got the geometric multiplicity 1 and its algebraic multiplicity is also 1. That is, algebraic multiplicity equals geometric multiplicity for all the eigenvalues. Therefore, we can say that M2 matrix is diagonalizable. Fine. So here, in this way, we have found that matrix M1 is not diagonalizable and M2 is diagonalizable. Fine. Therefore, here option B will be correct. Only M2 is diagonalizable. Fine. Just see how it is solved. Try to solve it, and if you have any doubt in any of the steps, tell me. And if it is clear, so tell me, we will proceed to the next question. No doubts? Shall we move to the next question? Okay. So next question is, question number 2 says that if the singular values of a 3 cross 3 symmetric matrix A, so you have been given singular values of the matrix A, symmetric matrix A, that is 0, 1 and 3. So you have to find the trace of the matrix A into A transpose. So calculate the trace of the matrix A into A transpose and find out, is it 4, minus 8, 8 or 10. So what are the singular values? Anyone? What is the singular value of a matrix, symmetric matrix? So if you have given a matrix A that is symmetric, and then the singular values are the absolute values of the eigenvalues of A. Fine. So here you have been given singular values as 0, 1 and 3. That is, these are the absolute values of the eigenvalues of A. Calculate the trace of the matrix A into A transpose. So hope you have calculated. Check your answers. So here the what is trace? It is sum of the diagonal values of diagonal elements. So trace of A into A transpose will be sum of square of singular values of A. So you have singular values as 0, 1 and 3. So square of 0 is 0, 1 is 1 and 3 is 9. So when you will add it all, you will get it as 10. Fine. So correct option is D. Solve it. Are you getting option D? It has option D. If you have doubt how you are getting it as the correct option, then tell me. You can either write your doubts in the chat box. So do you have any doubt in the question number 2 or its solution? Is it clear how to calculate its trace? Shall we move to the next question? Okay. So question number 3 is, if the eigenvalues of the matrix A, you have been given the matrix A, that is first row is 1 0 0, second row is 2 5 0, and third row is 1 2 5. So its eigenvalues are 1, 5 and 5 respectively. So what is the geometric multiplicity of eigenvalue 5? You have to calculate the geometric multiplicity of eigenvalue 5. Here you can see that algebraic multiplicity of eigenvalue 5 is 2. Now you have to calculate its geometric multiplicity. So calculate it as we have done in the first question, or you can even do it in another way, that is by calculating using the formula of number of variables minus rank of the matrix. So using any of the methods you can calculate it. You can simply use that formula of calculating geometric multiplicity as that is equals to number of variables minus rank of the matrix. Rank of the matrix A minus pi y. Because for eigenvector we calculate what? Ax equals lambda x. Here lambda is, here eigenvalue is 5. So lambda equals 5. So matrix is A minus pi y. So first calculate its rank. So what have you got? Is it 1, 2, 3 or 4? So you can calculate in this form also. So kernel of a minus pi y, how we are getting here a minus pi y? Since matrix A, you have to calculate the eigenvector of, that is geometric multiplicity. For that, we have to first calculate the eigenvector of the eigenvalue phi. So for that, you will consider ax equals pi y, 5x. So when you will take it on the left hand side, you will get a minus pi y identity matrix. So from there, we can simply calculate the geometric multiplicity using this formula, as kernel of a minus pi y is equals number of variables. So how many variables are here? 3. So 3 minus rank of this matrix a minus pi y. So what is the rank of this matrix? Can you tell me what is the rank of the matrix a minus pi y? Not a, rank of matrix a minus pi y. So first calculate matrix a minus pi y and tell me its rank. So when we will consider the matrix A minus pi y. So phi y means that matrix will have the diagonal elements as 5 and rest of the elements will be 0. So when you will subtract 1 minus 5, you will get minus 4. Here when you will subtract 5 minus 5, you will get 0. Similarly here when you will calculate 5 minus 5, you will get 0. And rest of the elements will be as it is. Fine, because here you have to subtract it from 0. You will subtract it from 0. So 0 minus 0, 0. Here 2 minus 0, 0. So rest of the elements will be same. Now you'll get elements over here and the third column will be 0 for a minus pi y. So from there only two linearly independent columns will be remaining. So rank of the matrix a minus pi y is 2. Fine. So 3 minus rank of a minus pi y, that is 2. So 3 minus 2 you will get 1. Hence geometric multiplicity of eigenvalue 5 is 1. Fine. So correct option is A. Solve it, are you getting? Or if you have any doubt, tell me. Have you got the rank as 1? Sorry, 2? So if you have no doubts, then shall we move to the next question? Fine. So here is your question number 4, that is, if the eigenvalues of a matrix A are 0, 1 and 2. So for matrix A we have 3 eigenvalues 0, 1 and 2. Then determinant of the matrix I minus A power 101 is. You have to calculate the determinant of the matrix I minus A power 101. Fine. So what will it be? 0, 1, 2 or 4? Calculate and find it. From these eigenvalues you can generate matrix A. So matrix A will be, arrange the eigenvalues of the diagonal elements, that will be 0. So you'll get in the diagonal elements you'll put it as 0, 1 and 2. So matrix A will be 0, 0, 0, 0, 1, 0 and 0, 0, 2. Fine. Now we have to calculate the determinant of this matrix. So first calculate the matrix I minus A. So you can proceed in this way. Matrix I minus A will be what? So when you'll subtract 1 minus, first element will be 0. So 1 minus 0 you will get 1. And second element 1 minus 1 you will get 0. And 2 minus 1 you will get, sorry, 1 minus 2 you will get minus 1. Fine. So this matrix eigenvalues will be also arranged diagonally. These elements are diagonally. So these are the eigenvalues also. So eigenvalues of I minus A is 1, 0 and minus 1. Fine. Now we have to calculate its determinant. The determinant of I minus A is, so for calculating determinant you can simply do what? Product of all the eigenvalues. This will also give you the determinant of the matrix, since the matrix I minus A is diagonal matrix. So just calculate the product of its eigenvalues. So you will get 1 into 0 into minus 1, that is 0. Fine. So determinant of matrix I minus A is 0. Now when you will take its power as 101, it will be again 0. Hence the correct option is A. Fine. Check it, are you getting? In any of the steps, if you have doubt, tell me. You have to form this matrix, then calculate its eigenvalue, that will be 1, 0 and minus 1. Then its determinant by calculating the product of all the eigenvalues. Since it's 0, so it will again give you 0. So shall we move to the next question? So question number 5 is, let x equals matrix minus 1, 2 be an eigenvector of the matrix A corresponding to the eigenvalue lambda. Fine. So there is one eigenvalue lambda, and corresponding to that you have been given one eigenvector x, that is minus 1 and 2, column vector minus 1 and 2. So if a square into x is equals minus 9 and 18 over here, then a possible value of lambda is, so you have to calculate the value of lambda, this eigenvalue lambda you have to calculate, and you have been given a square x is equals this column matrix and x is equals this column matrix. So find it, what is the possible eigenvalue? Is it -3, 5, 9 or 25? So for proceeding, what you can simply do is, since you know for calculating eigenvector we use a into x is equals lambda into x. So here as it is a square into x, so that will be equals to lambda square into x. Fine. So just equate a square x is equals lambda square x, where you have the value of a square x and matrix x is also given -1 and 2. So just put the values, you will get the value of lambda. will go like this. Since for calculating eigenvector for eigenvalue lambda, we do what? Ax is equals lambda x. So here you will get, since a square x you have been given, so here lambda square will come. So a square x is equals lambda square x. Now just put this matrix, that is minus 9 and 18 at this place, and at the place of x you put this matrix minus 1 and 2. Put it and equate the elements. So when we'll equate from first, you'll get it as lambda square equals 9, right? Minus lambda square equals minus 9, that will give you lambda square equals 9. So this will give you two eigenvalues minus 3 and 3. Okay, so from the options the correct option will be minus 3. So for this eigenvector corresponding to the lambda eigenvalue lambda, and given this conditions, you have found that lambda will be minus 3. Is there any doubt? So next question is question number 6, that says if the eigenvalue of a 3 cross 3 matrix A are 1, 1 and 2. Okay, then which of the following matrix is singular? Which of the following matrices is singular? So with this eigenvalue, you have to form one matrix A and find out which of these are is or are singular is singular. So first A plus I, is it singular? Or A minus 2I, is it singular? Or A square or A minus 3I? Which one of this is singular? Singular means its determinant will be 0. Okay. So find out. So what will be matrix A? Just arrange these eigenvalues in the diagonal at the place of diagonal elements, and rest of the elements will be 0. So you'll get matrix A. Matrix A will look like 1 0 0, then 0 1 0, and 0 0 2. So calculate each of the matrix and find its determinant. Tell me which matrix's determinant is 0. So calculate it. So for a plus I or a square or a minus 3i, the determinant values will not be 0. But for second option, a minus 2i, its determinant is 0. Okay. Since you can calculate its eigenvalue also, like 1 minus 2, you'll get minus 1, then 1 minus 2i, you will get minus 1, and then 2 minus 2, that is 0. So for calculating determinant, you will multiply all the eigenvalues, so that will be 0. Hence correct option is a minus 2i. So any doubt in this question? Please mute your mic. So hope it's clear. Simply calculate the eigenvalues of each of the matrices, and when you multiply all the eigenvalues, you will get the determinant of that matrix. So here for a minus 2i, you are getting determinant as 0. So this matrix is singular. Fine. Now, if there's no doubt, then we'll move to the next question. So question number 7 is, let the 2 cross 2 matrix A has eigenvalues 10 and minus 1. Okay, so you have a matrix A with eigenvalues 10 and minus 1. And the 2 cross 2 matrix B that has eigenvalues 10 and minus 9. So you have two matrices. For each of the matrices, you have been given the eigenvalues. So which of this is true? You have to find which of this statement is true. Okay. So find out is the power method converges faster in case of A, or the power method converges faster in case of B, matrix B, or the power method has almost equal rate of convergence in case of both the matrices, or the rate of convergence cannot be compared just by giving eigenvalues. So here, as you have been given only the eigenvalues of matrix A and B, so whether first you have to determine whether by using power method and using just the eigenvalues, can you determine which of these has faster rate of convergence, and if it is, then which of these have faster rate of convergence, A, B, or both have equal rate of convergence. So find it and let me know. So can you calculate, find out which of these have faster rate of convergence by using eigenvalues? So yes, by just using eigenvalues you can find it. How? Just find the ratio of absolute value of dominant eigenvalue upon the rest of the eigenvalue and find which one has faster rate of convergence. So you're saying option as B. Okay, let's see. So when you will calculate here the ratio, so for first one you will get it as, for matrix A, what will be matrix A? Just arrange the eigenvalues in the diagonal elements. So you'll get 10, 0, 0 and minus 1. Fine. And matrix B will be 10, 0, 0 and minus 9. Fine. Now you have to just calculate the absolute values of these eigenvalues ratio. That is, here the dominant one is 10 and the lesser one is minus 1, right? So just consider it. So here the absolute value of minus 1 will be 1 upon the other eigenvalues we have to take. So that is mod 10. So 1 upon 10 you will get 0.1. Here when you will divide, so just take mod of minus 9, that is lambda 2. So 9 upon modulus of 10, that is 10. So 9 by 10 you will get 0.9. So actually you have to calculate the ratio of the eigenvalues, absolute values of eigenvalues, and in the numerator you have to take the one with the less value, that is smaller one. So 1 by 10 you will get 0.1 and here 9 by 10 you will get 0.9. So which one has the faster rate of convergence? That is A. Fine. I hope it is clear now. Is it clear? Shall we move to the next question? So if it is clear, then let's move to the next question. Have you understood that problem? Why it is A not B? I hope it is clear. In question number 7, why it was A option? Okay, fine. So question number 8 is the approximation of the dominant eigenvalue after two iterations of power method for the matrix A equals 6 minus 2 2 minus 2 3 minus 1 2 minus 1 3 with initial iteration x of 0 equals, that is the initial iteration you have given 1 1 and 1. So what is its value? 6.33, 7.33, 7.79 or 8.33. So the approximation of the dominant eigenvalue using two iterations of power method you have to calculate, and initial iteration you have been given. So calculate it. Okay, let the others calculate using the power method. So here correct option is B. You will get it as 7.33. Okay. So first of all, by using we have to calculate it using power method. So in power method, what we do exactly? First, we assume that the matrix A has a dominant eigenvalue with corresponding dominant eigenvectors. Okay. So then we choose an initial approximation. Here it is x0, that is given as the initial approximation, and one of the dominant eigenvectors of A. From that, this initial approximation must be non-zero vector in Rn. Fine. So using that, you will get the sequence of approximations in each of the iteration, like x1 equals ax naught and x2 will be ax1. That is, in place of x1 you can put ax naught. So you will get a square x naught. Similarly, you have to go on doing. Okay. So now here, as you can see, first you will take, using power method, you will take the first matrix as a into x naught. So yes, after two approximations you have to give the answer. Okay, so after two approximations, are you getting 7.79? Here it has been done only for first approximation. Okay, fine. So here I might have missed out with the second approximation. So for first approximation, when you will calculate a into x naught, by matrix multiplication you will get 604, and by scaling it down, that is, for scaling you will just take divide whole of this terms with the highest element, that is 6. So when you will divide by 6, you will get 1, 0 and 0.667. Okay, I got it. Here I have missed out with the second approximation. Fine. So according to you, we are getting second approximation as 7.79, right? Okay, fine. So from first approximation, you will get 7.33 minus 2.6 and 4. From there, you will get the dominant eigenvalue as 7.33, right? And when you will calculate for the second approximation, you will get 7.79. Check, others check, are you getting it as 7.79 after two iterations? And if it is asked, I think here it is mistake in the question. It should have been asked as for the first iteration itself. So you will get it as 7.33. Okay. And if it is asked for two iterations, then check, are you getting it as 7.79? So shall we move to the next question? Is it clear for everyone? It is after 2 iterations, not after 2 approximations. This AX1 that you have calculated, it is first iteration. Then you will move to the next iteration. Yes, after 2 iterations. Okay. But actually in this question, it should be after 1 iteration. Okay. So you will get it as 7.33. Fine. Now, shall we move to the next question? Is it done? Shall we move to the next question?
Yes, ma'am.
Okay. So next question is, question number 9 says that let the matrix B is obtained by applying 2 iterations of Jacobi's rotation method to the matrix A. Okay, so using Jacobi rotation method on matrix A, you will get matrix B. Then consider the following statements. The first statement says that sum of diagonals elements means other than diagonal elements of A are greater than sum of diagonal elements of B. Okay. So first statement says that sum of diagonal elements of A are greater than sum of diagonal elements of B. And second statement says that sum of diagonal elements of A equals to the sum of diagonal elements of B after Jacobi's rotation method on A. So which one of the statement is true? Either one is true, second is true, both are true, or neither of them are true. Okay. So here both the statements are true. Okay. Even sum of diagonal elements of A are greater than sum of diagonal elements of B. Fine. Okay. So this is all for this session. We have discussed all the 9 questions for today, and lot of you have joined later. So shall I just go through all the questions once again from the first question, what we have discussed. Okay. So first question was, determine which of these matrices is diagonalizable. Either M1 is diagonalizable or M2 is diagonalizable. Okay. Can you calculate it? So for calculating which one is diagonalizable, you have to calculate its algebraic multiplicity and geometric multiplicity of each of its eigenvalues. And if AM is equals GM, that is algebraic multiplicity is equals GM of all the eigenvalues, then that matrix will be diagonalizable. So using that, you can find out that M1 is not diagonalizable, whereas M2 is diagonalizable. Okay, so you have done it over here. As you can see, from matrix M1, you will get characteristic polynomial as x square minus 2x plus 1 equals 0, which will give you one eigenvalue 1. So its algebraic multiplicity will be 2. Now, when you will calculate it eigenvector, that is eigenspace, you will get only one linearly independent eigenvector. Oh, sorry, vector. So its geometric multiplicity is 1. So here algebraic multiplicity of 1 was 2 and 1 is 1. It's not equal. So M1 is not diagonalizable. Now for M2, similarly we have done. So here we have got two eigenvalues, 1 and minus 1. Okay. Now calculating the geometric multiplicity of 1, you will get it as 1, and the geometric multiplicity of minus 1, you will again get it as 1. Okay. So here for both the eigenvalues, algebraic multiplicity is equals geometric multiplicity. Therefore, M2 is diagonalizable. Okay. So hence we've shown that M1 is not diagonalizable and M2 is diagonalizable. Okay. Is it clear? Okay. So next question is, if the singular values of a 3 cross 3 symmetric matrix A are 0, 1 and 3. Okay, you have been given the singular values. Then the trace of the matrix A into A transpose is, we have to calculate the trace of the matrix A into A transpose. What is the meaning of singular values of the matrix? Symmetric matrix. It is nothing but its absolute values of the eigenvalues, right? The absolute values of these eigenvalues will be again 0, 1 and 3. And for calculating, first you have to calculate A into A transpose. So trace will be the sum of square of singular values of A. That is 0 plus 1 plus 9. That will give you 10. Hence correct option is D. Okay. Now next question is, if the eigenvalues of matrix A are 1, 5 and 5, then you have to calculate geometric multiplicity of eigenvalue 5. Okay. So for that, you can simply use this formula, kernel of A minus phi by. Why we are using A minus phi? Because we have to calculate geometric multiplicity. For that, we need eigenvector. So for eigenvector, we consider Ax is equals lambda x, that is 5x. So when you'll take it on left hand side, you'll get A minus phi y. So kernel of the matrix A minus phi I is equals the number of variables minus rank of that matrix A minus phi y. So this will give you 3 minus 2, as A minus phi y will have only two linearly independent columns. This third column will be 0 for this matrix. So you will get it as 1. Hence geometric multiplicity of eigenvalue 5 is 1. Okay. Is it clear? Is it clear? Shall we move to the next question? Do you have any doubt? Singular values are the absolute values of the eigenvalues. Okay. So next question is, if the eigenvalues of a matrix A are 0, 1 and 2, then what will be the determinant of the matrix I minus A power 101? So for that, first you need to calculate the matrix I minus A. It will be again simply the, when you will subtract the diagonal elements, so 1 minus 0 you will get 1, and 1 minus 1 you will get 0, and 1 minus 2 you will get minus 1. Now its determinant will be just multiplication of all the product of all the eigenvalues. So it will be 0. Hence its power 101 will be again 0. So correct value is 0. Okay. Now next question is, let x is equals this column vector minus 1, 2 be an eigenvector of a matrix A corresponding to the eigenvalue lambda. If A square x is equals this matrix minus 9 and 18, okay, then a possible value of lambda is, so for given eigenvector and given this value, you have to calculate the eigenvalue lambda. For that, we know that when we calculate eigenvector, we just put Ax equals lambda x. So A square x is equals lambda square x. This will give you lambda square is equals, when you will substitute both these values in this equation, you will get lambda square equals 9. That means lambda is equals to minus 3 or plus 3. Therefore, the correct option is A. Okay. Till now, do you have any doubt? If it is clear, shall we move forward? Shall I proceed? Okay. Next question is, if the eigenvalue of a 3 cross 3 matrix are 1, 1 and 2, then which of the following matrix is singular? So you just need to find a determinant of which of the matrix is 0. So for A minus 2i, you will be getting eigenvalues as minus minus 1 and 0. So product of this will be 0. So determinant of A minus 2i is 0. That means this matrix is singular. For others, you will not get determinant as 0. Okay. Next question is, let the 2 cross 2 matrix A has eigenvalues 10 and minus 1, and the 2 cross 2 matrix B has eigenvalues 10 and minus 9, then which of the following is true? That is first question. First says that power method converges faster in case of A, or it converges faster in case of B, or both have equal rate of convergence, or we cannot determine. Okay, so we got here it as option A. It converges faster in case of A. Okay. Now in question number 8, for this you have been asked for the only one iteration of power method for this matrix. just you need to find the dominant eigenvalue only for one. Okay, one iteration. So after one iteration, you'll get Ax naught is equals to 604, and after scaling, you'll get this matrix. After first iteration, that is Ax1, you will get 10 and 0.667. Just a minute. This is actually two iterations, right? First iteration is this one, Ax naught equal to, so you'll get 604, and this Ax1 is second iteration. So it's correct. After two iterations of power method only, you are going to get this. Okay. Here there are two iterations. This is first iteration, that is Ax naught. You'll get x1, and in second iteration x2 equals Ax1. Okay. So hope it is clear now. The question is correct. You have two iterations here, and after two iterations we are going to get 7.33. Is it clear now? Is it clear? This question is clear now. We have two iterations, and after two iterations only you are going to get 7.33, not 7.79. Okay. If it is clear, we will move to the next question. Shall we proceed? Okay. And the last question is, for given matrix B after two iterations of Jacobi's rotation method to the matrix A, which of these statements is true? So first statement says that sum of off-diagonal elements of A are greater than sum of the off-diagonal elements of B, and second says that sum of diagonal elements of A equals sum of diagonal elements of B. Okay, so we found that no, after two iterations means, see here, first iteration is what? First you have been given the initial value, that is x naught. Now first iteration will be x1, and x1 will be what? Is equal to a into x naught. Okay, so first iteration is x1 equals a into x naught. So you'll get this 6, 0 and 4. After scaling, x1 will be 1, 0 and 0.667. Okay. Now you will proceed for the second iteration, that is x2. So x2 will be what? A into x1. So this is our second iteration. This was our first iteration. Okay. So these are two iterations. Ax2 will be third iteration. X3 equals Ax2 will be the third iteration. Okay. That you are asking about. Got it? Okay. So this question is correct, and after two iterations we are going to get 7.33. And in the last question, both of the statements are true. Okay. Okay. So this ends with the week 3 session. Do you have any doubt related to the questions we have discussed? You can ask. This presentation slides will be shared to you, and also this meeting will being recorded, and it will be uploaded on my YouTube channel, so you can refer to it. Link will be shared to you. Hope this session was helpful for you to solve the week 3 assignments. If you have any doubts, you can ask. So, was this session helpful? If you don't have any doubt, we can end up with the session. Hope this was helpful for you. Thank you everyone for joining. You are asking how to find Jordan canonical form. Uh, it has been given in the YouTube videos. Have you referred to the lectures? Week 3 lectures, have you gone through it? Okay, so first just go through the lectures. You will find there the whole procedure is explained over there, how to find the Jordan canonical form. And for that, you just need to calculate like a minus lambda I times v equals 0 and counting the numbers of R1 linearly independent solutions, you will get through it. Okay. So for that, first you go through the video lectures. Okay. Any doubts related to the assignment problems we have solved? Is it clear everything? Okay. So thank you everyone for joining. And for this, with this, I'm ending this meeting. Thank you everyone. We'll meet in the next session. Okay. Thank you. Yeah. Say. Do you wanna say anything? Uh, okay, you're asking that is there any difference between finding singular values for square matrix and symmetrical matrix? Yes, for normal square matrices, it's square root, and for symmetrical matrices, it's absolute value. Any other questions? So with this, I'm ending with the session. Thank you everyone for joining. Let's meet in the next session. Okay.